The next several problems have us identify the parent function, to identify what transformations are happening to that parent function, so how is it moving, and then to graph the parent function. So the first one here, number 4, the parent function is absolute value, and I know that based off of these bars. So absolute value tells me the shape of the graph, and that tells me that this shape is going to be the V. Typically the V has a vertex at 0, 0, but ours is going to be moving. The -2 on the inside is a right 2, and the +5 on the outside is an up 5. So I'm going to go right 2 and up 1, 2, 3, 4, 5. And there's no indication that this opens down. There's no negative here, so I'm going to kind of draw it going off my graph here. That's my graph. It's a V. It opens up. It has been moved right 2 and up 5. Then for question number 5, the parent function is quadratic. This 2 tells me it's a quadratic function, and I know that quadratic functions have the shape of a parabola, which kind of looks like a U. And there's a couple of things happening here. One, the +1 is an up 1, so I'm going to take my vertex and move it up 1. The negative there is going to be an opens down, or a reflection over the x-axis, and the 1/2 is a compression. A compression indicates that it's going to be wider than a typical parabola. So when I graph this, my vertex is typically at 0, 0. I'm going to move it up 1. And then typically I would go out 1, down 1 to open it down. But I'm going to go out 2 and down 1. Out 2 and down 1. And then I would go out 4 and up 4. So 1, 2, 3, 4. Up 4, up 4. Now again, you don't have to have that perfectly drawn, but you should indicate that this is a wider parabola than the one that goes through 1 out 1 down 1 out 1 down. So this is certainly wider than that standard parabola. Let's try the next two as well. For number 6, the parent function is square root. I know that that is going to be the function that looks like this, starts at 0, 0 and kind of goes up and to the right. But ours is being transformed again, so the first is that it's going to go left 2 because of the +2 inside. And then the 4 that's being multiplied is a stretch, meaning it's going to be taller than my standard. So I'm going to take my vertex that's typically at 0, 0. I'm going to move it left 2 and place it here. And typically I'd go out 1, up 1, but I'm going to go out 1, up 4 to show the stretch. So this is much taller than my standard square root function. And I'm going to kind of go off my graph again here. But it's much taller than the standard square root function. The last example I have here just has the x part, and so this is a linear function, and the -1 on a linear function is going to move us down 1. So typically my graph would start at 0, 0, but instead ours is going to go through -1 on the y-axis, and the slope is 1, so we're going to go up 1, right 1, and so on. This is one you should be able to graph perfectly. So I'm going to connect my dots here to show my linear equation. So, things to remember. Anything that's happening inside the square root or inside the absolute value in the case of number 4 or inside parentheses is moving left and right. Subtracting moves us to the right, addition moves us to the left. Anything that's outside those parentheses is going to move us up and down. And so in this case, subtracting moves us down, addition moves us up. The last couple of things to remember is that if there's a negative being multiplied by the x in some form or fashion, it's going to cause us to open down. And then if you're multiplying by a number greater than 1, it's a stretch. It's going to be taller and skinnier than your standard function. And if you multiply by something less than 1, like this 1/2 here for number 5, your graph should be wider than the standard function.